Morocco is facing severe water conditions and rapidly increasing water demands, two constraints that require the mobilization of new water resources. Irrigation with treated wastewater is justified by the valuation of the nutrients it contains, as well as by energy savings due to the reduction of water pumping. However, this unconventional resource is not suitable for all water uses unless there is a constant monitoring of effluent quality at the treatment plants. As early as the 1980s, pilot actions have been implemented in several cities to test the effectiveness of different modes of wastewater treatment with respect to decontamination and agricultural reuse. In Ben Sargau, a commune of Greater Agadir, wastewater is treated by infiltration percolation. The experiment focused on the irrigation of plantations of vegetable crops and grass in both open field and greenhouses. All consumer products, such as tomatoes, have been subject to bacteriological and parasitological tests that were negative. A portion of the city's water was treated in an experimental lagoon. 60 land plots were irrigated for 5 years using water with different quality levels and various irrigation systems. Drip irrigation proved to be the most appropriate mode. The Water Law 1095 provides that an integrated sanitation system includes water reuse wherever possible. The discharge of treated wastewater into the sea should thus remain an exception.
La stratégie nationale de l'eau a fixé comme objectif dans l'axe gestion et développement de l'offre la réutilisation de 300 millions d'eaux usées épurées à l'horizon 2030.
The implementation of the National Sanitation Plan in 2006 resulted in the construction of wastewater treatment plants in a large number of urban communes. The reuse of treated wastewater for agricultural purposes is a priority, as agriculture is the country's largest consumer of water. Decontaminated wastewater also serves for artificial groundwater recharge when the subsoil is suitable for this purpose, contributing thus to the protection of aquifers. Industrial wastewater is reusable when a company consumes large amounts of water that unduly increase manufacturing costs. Recycling becomes therefore a cost-saving opportunity. The OCP Group has now created a process of industrial water reuse, unique in Africa, for washing ores using the influence of the Kharibga treatment station. In the domestic sphere, the reuse of treated wastewater has not been a priority yet. In 2011, a quarter of the raw wastewater produced in the kingdom was treated, that is to say, 175 million cubic meters of treated wastewater per year, a volume that has been increasing as the demand for drinking water supply rises and as the National Sanitation Plan makes progress. Treatment systems intended to decontaminate domestic or industrial waste are varied.
L'épuration, nous sommes actuellement, on dispose de 56 stations d'épuration, soit un taux d'épuration de l'ordre de 20% actuel, et on compte atteindre 40% à l'horizon 2020.
Treatment always includes a pre-treatment with screening, grit removal and oil separation. In most coastal cities, pre-treated wastewater is currently discharged into the sea. Pre-treatment is usually followed by several more or less complex treatment stages, including various decanting processes to separate suspended soils in the liquid, in addition to the water oxygenation phase. The level of decontamination differs according to the type of treatment process. Compact systems have a low space requirement. They consist in accelerating the natural processes of water decontamination using costly chemical or physical processes due to their heavy energy consumption. Extensive systems take up more space. They are also called ecological systems because decontamination occurs naturally, either by filtration into the soil or by leaving wastewater to stay in various lagoons. In 2011, about 71% of treatment plants in Morocco belong to the extensive type. With 20 treatment plants in 2005, Morocco has accelerated its achievements since then. Under the National Sanitation Plan, there will be 152 such plants by the year 2020. Wastewater quality standards are set by law. They vary according to the intended use. The biological constraints were updated by the World Health Organization, taking into account health hazards to farmers or consumers. These constraints are related to the minimum effective dose. Actually, it only takes one parasitic worm egg to cause serious health hazards. Hence, the need to establish constraints on water use for agricultural purposes. The cereal, industrial, or tree crops cultivations can be irrigated with treated wastewater. This is what we call Type C constraints. They set no limits regarding the microbiological quality when irrigation belongs to the localized type because it eliminates any risk of contact with humans. For their part, Type B constraints meet the standards as a priority for parasites. The effluent must have a value below 1 helminth egg per liter to protect the health of workers. This constraint applies the gravity irrigation of cereals, forage crops, and vegetables that are consumed after cooking. Type A constraints, the most severe. They combine the absence of helminth eggs and a limit of fecal coliform content of up to 10,000 per liter as a value necessary to prevent the spread of infectious diseases. Chemical restraints are weak when it comes to household wastes. Most municipalities have opted for a short treatment process without any tertiary treatment, deemed unnecessary for the reuse mode contemplated, which is a significant saving in investments. This map of 2010 shows that in some water basin agencies, such as those of Tensift, Souss-Massa, and Moulouya, the volume of treated water now largely dominates over the wastewater discharge row. Taking into account the aridity of these regions, the reuse planned by the water basin agencies will be a rapid process. Presently, 70 sewage treatment plants have been set up under the National Sanitation Plan and 34 are underway. Eventually, all these plants will produce nearly 1 billion cubic meters per day of treated wastewater. 17 projects involving the reuse of treated wastewater are now underway, and more than half of them deal with the irrigation of golf courses. In Ben Sliman, Essaouira, and Bouznika. Regarding Marrakesh, the project that has been completed was the first of its kind on the African continent. In Agadir, the treatment by infiltration percolation provides, without any further treatment, effluents with quality A, which are used to irrigate a golf course and some urban green spaces. The use of agricultural purposes, which takes a long time to put into place, still accounts for only 12% of the volume of treated wastewater. In Satat, a sewerage system connected to a full lagoon chain was installed. At the exit of the treatment plant, quality A effluents may be used for irrigation without any health risk. A storage pool can cope with periods of high demand. Groundwater recharge by spreading treated wastewater is also planned at the water basin agencies of Lucas, Cebu, Burgreg Shawia, Susmasa Dara, and Girziz Riz. For example, a portion of the effluents from the wastewater treatment plant of Bugra seeps into basins intended for this purpose in order to recharge the highly deficient water table. Wastewater recycling in industries has been growing rapidly in Morocco. Industrial pollution abatement is accelerating thanks to the support of FODEP. 60 projects have been approved and 40,000 cubic meters per day of toxic industrial waste are now cleaned. The legal text governing the implementation of the water law provides two instruments to water basin agencies as bodies responsible for the quality of treated wastewater discharges: the prior authorization for any discharge and the payment of the tipping fee corresponding to the discharge. It is in the basins of Cebu and Burgreg that wastewater reuse will be the most significant. Programming of this reuse aims to use 21% of production by the year 2020. More than 24 projects have been initiated for a total of 170 million cubic meters per year, distributed as follows: 49% for agricultural irrigation in Fez, Meknes, and Oujda, 38% for golf courses in Marrakesh, Agadir, and Essaouira, 5% for groundwater recharge in Kenitra and Bugra, 8% for washing phosphate ore in Youssoufia, Bengurir, and Khouribga.
En 2030, on atteindra les 30% fixés par la stratégie si on intègre une partie des eaux usées qui sont déversées en mer. Il y a une grande partie, environ 60% d'eau usée actuellement, qui est rejetée directement sans aucun traitement vers la mer. Donc si on intègre une partie de ces eaux usées, on va atteindre l'objectif fixé par la stratégie, à savoir 300 millions de mètres cubes d'eau usée à l'horizon 2030.
Reclaimed water will be used for the irrigation of crops, green spaces, and golf courses in Tangier, Tétouan, and Casablanca. In the latter city, part of this water will be used for artificial groundwater recharge. The reuse of treated wastewater will grow rapidly by 2030. Alongside the rapid development of wastewater treatment plants in the kingdom, reaching 32% of the volume of treated wastewater in 2030. It is vitally important to promote awareness of all users to water saving in all areas, in order to advance the concept of treated wastewater reuse. To avoid wasting the resource represented by these massive wastewaters which are discharged into the sea, it is necessary to recycle these waters even if the treatment cost seems high. It is also a way to preserve our non-renewable groundwater resources.